Have you ever wondered how scientists study the composition of distant planets and moons in our solar system? From the dawn of time, humans have been fascinated with the cosmos. The stars, planets, and other celestial bodies have stirred our curiosity, inspiring countless myths, stories, and scientific inquiries. Today, we have the technology and knowledge to reach beyond our planet and explore the vast expanse of space. One of the most intriguing aspects of space exploration is understanding the composition of distant celestial bodies. By studying the elements and compounds that make up these bodies, we can gain crucial insights into their history, their potential to support life, and their overall place in the cosmos. This knowledge is not just fascinating, it's essential, as it helps us understand our own planet better and potentially how life originated here. So how do scientists manage to study these far-off planets and moons? Let's dive in. The first step in studying the composition of celestial bodies is through telescopic observations. Now, you might wonder, how does a telescope, a device that's either stationed here on Earth or floating around in space, give us information about the chemical makeup of far-off planets and moons? The answer lies in the magic of light. When we gaze at a celestial body through a telescope, we're not merely appreciating its aesthetic appeal. We're capturing the light that it emits or reflects. This light, believe it or not, carries a wealth of information about the object it's coming from. But how do we decode this information? Enter the science of spectroscopy. Spectroscopy is a powerful tool that allows scientists to analyze the light captured from distant celestial bodies. It works on the principle that when light passes through or bounces off a material, it gets altered. This alteration, or spectral fingerprint, is unique to the material, acting much like a barcode that reveals the substance's identity. Let's imagine this process in action. A telescope captures the light from a distant planet. This light is then passed through a spectrograph, a device that separates the light into its individual colors, much like a prism, creating a rainbow from sunlight. Each element in the universe absorbs or emits light at specific wavelengths, resulting in a unique pattern of dark or bright lines in the spectrum, known as absorption or emission lines. By observing these lines, scientists can identify the elements present in the celestial body, from hydrogen and helium, the most abundant elements in the universe, to traces of heavier elements like carbon, nitrogen, oxygen, and even metals. Spectroscopy gives us a detailed chemical inventory of distant planets and moons. This process is akin to a cosmic detective story where light is our clues and spectroscopy is our method of deciphering these clues. With each observation, we're peeling back the layers of the universe, uncovering the secrets that these celestial bodies hold. With this information, we get the first glimpse into what these distant planets and moons are made of. The next step is getting a closer look through space probes and rovers. So, what exactly are these space probes and rovers? They are essentially our eyes and hands in the distant reaches of the cosmos. Designed and built with meticulous care, these marvels of technology are sent on missions, sometimes millions of miles away, to gather data about celestial bodies. These probes and rovers are equipped with a variety of tools and instruments. Imagine a robotic geologist, chemist, and photographer all rolled into one. They dig into the soil, sift through dust, and sometimes even drill into rocks. They collect samples of these materials to analyze and study, giving us a direct insight into the composition of these celestial bodies. But collecting samples isn't their only job. They are also equipped with cameras, capturing stunning images of the landscapes that they traverse. These photographs are not just for our viewing pleasure. They help scientists understand the geology of these bodies, revealing details about their structure and the processes that have shaped them over time. In addition to this, these probes and rovers conduct a variety of experiments. They measure temperature, atmospheric pressure, and magnetic fields. They even look for signs of water and, in some cases, the building blocks of life. All this information is then beamed back to scientists here on Earth, providing us with a wealth of data to study and understand. These exploratory missions are not without their challenges, though. The harsh conditions of space, the vast distances, and the extreme environments on these celestial bodies pose significant hurdles. Yet, despite these challenges, space probes and rovers continue to push the boundaries of our knowledge, venturing into the unknown and bringing back a treasure trove of information. And it's through these missions, these journeys of exploration, that we get to know our cosmic neighbors a little better. We start to understand their pasts, their presents, and perhaps their futures. These exploratory missions provide us with invaluable, detailed information about the composition of these celestial bodies. Once we have the data and samples, it's time for some lab analysis. Our journey into the mysteries of the cosmos doesn't end with the collection of data and samples. In fact, it's only the beginning. The real magic unfolds in laboratories, where scientists use a range of techniques to analyze and interpret this valuable information. Think of the lab as a detective's office, where every clue is scrutinized, every piece of evidence is examined under a microscope, literally and figuratively. The data and samples collected by telescopes, space probes, and rovers are like puzzle pieces, and our scientists are the master solvers, piecing together the story of our solar system. One of the most commonly used techniques is spectroscopy. By examining the light emitted or absorbed by a substance, scientists can determine its composition. Each element has a unique spectral fingerprint, and by analyzing these spectral lines, we can figure out what distant planets and moons are made of. Mass spectrometry is another key tool. It's used to identify and quantify the amount of specific elements in a sample. This technique was crucial in confirming the presence of water on Mars, a significant discovery that opened up a whole new realm of possibilities for life beyond Earth. Then there's X-ray diffraction. This method allows scientists to study the structure of crystalline materials. By probing how X-rays are diffracted by a sample, we can gain insights into its mineral composition and structure. And let's not forget about the power of imaging. High-resolution images of distant celestial bodies, captured by telescopes and space probes, are meticulously analyzed. Every mountain, every crater, every valley tells a story about the geological processes that have shaped these alien worlds. These laboratory analyses don't just confirm our initial findings from telescopic observations. They expand upon them, providing a more detailed and nuanced understanding of our cosmic neighborhood. Each analysis, each discovery, takes us one step closer to answering the age-old question, are we alone in the universe? With the help of laboratory analysis, we can delve deeper into the mysteries of our solar system. The final step in studying the composition of distant celestial bodies is computer modeling. This process is a bit like piecing together a cosmic jigsaw puzzle, and it's where the magic really happens. Scientists take all the data they've gathered through telescopic observations, space probes, rovers, and laboratory analysis, and feed it into sophisticated computer programs. These programs have the capacity to crunch massive amounts of data and translate it into a visual, three-dimensional model of the celestial body in question. Think of it as a digital replica of a planet or moon, right there on the scientist's computer screen. These models are incredibly detailed, right down to the tiniest rock or the faintest layer of atmospheric gas. They're built layer by layer, element by element, until a complete picture emerges. But these models aren't just static images. They're dynamic, interactive representations that can be manipulated and observed from all angles. Scientists can virtually walk on the surface of these models, peer into their craters, scale their mountains, and probe their atmospheres. What's more, these models are not just about understanding the present state of these celestial bodies, but also about predicting their future. They help scientists forecast how these bodies might evolve over time, how their atmospheres might change, or how their surfaces might be reshaped by geological activity. In essence, computer modeling is a powerful tool that allows scientists to explore outer space without leaving their desks. It's a kind of virtual reality where distant worlds come alive in the digital realm, providing a wealth of information that would be impossible to gather through direct observation alone. Through computer modeling, we can virtually explore these distant worlds and gain insights into their composition. It's a fascinating process, and one that continues to push the boundaries of our understanding of the universe we live in. Also, from telescopic observations to computer modeling, the journey of studying the composition of distant celestial bodies is a fascinating one. We've traveled through the cosmos, not physically, but through the power of human curiosity and technological advancement. We've peered into the vast expanse of space using telescopes, capturing the light from far-off worlds, analyzing that light to discern the composition of those distant planets and moons. We've sent out space probes and rovers, daring explorers that have touched the surfaces of other worlds, sampling and studying their makeup. Back on Earth, we've replicated these alien environments in our laboratories, trying to understand the intricate details of their formation and evolution. And finally, we've used the power of computer modeling, simulating countless scenarios to help us predict and comprehend the mysteries of the universe. Every step in this process, each discovery made, takes us closer to understanding our place in the cosmos. Next time you look up at the night sky, remember the incredible journey of discovery that each distant point of light represents.